This is, as far as we're concerned, this is chapter 4, lesson 4. Not chapter, unit 4, lesson 4. No, it was just a small example. Do not worry about it. Okay, so when you graph a system of equations, you're just looking for where both parts are shaded, and that is your solution. Now, before we go straight to another graphing problem, never mind, just kidding. We're going to go straight to another graphing problem. Now, what is the first step we have to do on these equations? Solve for y. There are multiple ways to solve for y, and we've already done it before, so I want you to take a minute and see if you can solve both of those for y. There are multiple ways to do it, and I will do it as well. Yes. Yes, you do. And let's see if we get the same thing. That's correct.
I thought we were solving for y.
You are.
He's doing it a different way.
Yeah, I said there's a ton of different ways you can do it.
He's doing it the hard way. How is that solving for y? He's solving for x.
Why?
Wait, but on the first one it's not like that.
That's just because, well, you work it your way, I'll work it my way, then we'll talk about it. Whenever you're done, check yours with mine. The two red lines are our finished products. I did them both different ways to show you you can do it either way, but if you do it like the bottom one, I got the y by itself right off the bat. I subtracted the x, but I had negative y is greater than 3 minus x.
You said y can't be negative.
Right. Y can't be negative. So you had to multiply everything by negative 1. And when you do that, what do you have to remember to do?
Flip the side.
Flip your inequality. That's right. Which is why when I multiplied everything by negative 1, I just flipped my inequality. However, sometimes I like to avoid doing that step. That way I don't have to remember to flip the inequality, which is why I did this one differently. I added the y so that it would be positive, and I wouldn't have to remember to flip my sign, and then I just added the 1. But it's the same thing. You get y is greater than x plus 1, and y is less than x minus 3.
Wait, I have different signs. I do too.
Uh-oh. What do you have?
Y is greater than 1 plus x.
Okay, check.
Alright, and then y is less than negative 3 plus x.
Same thing. Only difference is the order we wrote them. Negative 3 plus x, 1 plus x, same difference. Exact same thing. Anybody else get something different they'd like for us to take a look at? Now, if I ask you to graph these and find the solution of the inequalities, I'm just going to quick sketch these. Oh, I can't do that. Just a quick sketch. And that would be, let me just give myself 2 quick lines. Now I'm just going to quick sketch these to save time. But if I was doing this one first, that would be y-intercept of 1, slope of 1, dotted line. And the top one, y-intercept of negative 3, slope of positive 1 again. What do you call these kinds of lines? Thank you, Tyler. They're parallel. So are they ever going to cross? No, they are not. Well, technically that's true. You could also call them red, but that would have been equally as productive. Now, the blue one, the one I did in blue, are we supposed to grade above or below that?
If you're above.
Above, because y is greater than x plus 1, which would be up here. Now, the green line, is that above or below? Below. Now,
blue one. You said green.
Green one.
That's a green.
I'm in the green equation. Now, technically, this would be no solution because we're looking for where both of their shadings overlap. Does that happen anywhere?
No.
No. So technically, this would be no solution. And here's a better picture of that graph. This is exactly what we just did. See? The no solution symbol. Because this shading and that shading never cross.
Why don't we write the bubble?
What? Go ahead. You mean instead of writing no solution?
No, like. Do we still have to write the consistent? The chat.
No, not for inequalities. What?
The chat bubble thing.
The chapped bubble?
Little
The
bubble.
one that has the math in
The
it.
speech bubble. The speech bubble. Right there, the speech bubble.
No, right there. Right there.
The speech bubble.
Yeah.
The thought bubble.
Why don't we?
Yeah.
I guess you could. I
Is
guess you
it
could.
important? What is it?
You're asking questions. How do you know if you do the dotted line or Cameron?
Go back to your equation. Okay, well darn if these aren't. You see our original equations, how they both had less than and greater than? Are there an equal sign underneath either of those? If there's no equal sign, it's dotted. If there is an equal sign, it is a whole line. That is an excellent question. Sorry. Another question. Yes, sir.
Why is that equal?
Whereas, well, oh, they shouldn't be. I think they were just trying to point out which line was which. It was they shouldn't be.
Why is one equal?
These equal signs because they weren't equal originally. I think I copy pasted that straight from the book, so they were probably just in a hurry. Other questions?
You're messing everything up in the book.
No other questions?
Better.
All right. Now, before we go on, here's a nice visual. The blue is one shading, the orange, whatever, is another shading, and the green is where they overlap. It gives you 3 coordinates, and you're supposed to say, are those coordinates solution to this system of inequalities? What about the coordinate 3, 1? Is that in the solution?
Yes.
3, 1, it looks like it is. Very good. What about 2, 3?
No. No.
2,
Yes.
Yes.
3.
No.
It's right on the line.
Yes.
So no.
Yeah. Yes.
Well, let's think about it like this. Is 2, 3 greater than the dotted line?
No.
Is it above the dotted line?
Yes.
Yes. Is it less than or equal to the solid line?
Yes.
So it's yes for both, so it would be yes. Now, if it was on this line, it would be no. Because,
no, then the next one.
is the next one on the line?
Yeah.
3. Oops. That one would be no, because it's on the dotted line, which is non-inclusive.
Well,
I didn't realize.
Where'd the black?
I'm confused.
Where'd
How
it
do you
go?
know if it is or isn't? The black
What?
box. How do you know if it is or isn't? Like,
A solution?
yeah, if it's on the line.
If it's on the line, if it's on the solid line, remember solid lines mean is also equal to, which means like those points are included, which is why that one was a yes. The dotted line means that's the boundary, but those points aren't actually included. It has to be greater than those points or less than those points. So because it was on the dotted line, it didn't count.
So solid line, yes, and dotted line, no.
Yes.
Like always?
Well, I mean, if the solid line borders, I mean, if it had been down here, it'd still be no, because it's not in your shaded region. But yes. Leslie, did I answer your question? Good. You're going to have 3 of those later. Now, I'm going to tell you right now, I'm going to pretty much give you the same problem later, except it'll be instead of ACE, BDF. So later when you get your assignment and it says like blah blah BDF, you're like, what's BDF? That just means do those portions of that problem. All right, now back to the graphing. Back to the graphing. Most of today is graphing and shading.
X equals 6 or more. That's what will make that equation true.
Yes. But I still need the graph. The graph,
I'm 100% correct.
you're kind of 100%. That's actually not true. You said 6 or more, right? So by your definition, 5.1 is false. But 5.1 is true. Now, but I like how you're thinking. Now, how do I graph x is greater than 5?
Go up 5. And then
Here's the one thing about that. Up 5 would be 5 on the y-axis. You're looking for 5 on the x-axis. Boy, I like how active we are today. All right.
I started all this.
What did he say?
I started all this.
It's Monday.
Thank you, Tyler. It's dotted because it's not equal. Now, do I shade to the right or to the left?
Left.
shade that to the right.
To the right.
Still
Because the variable is greater than the number, and greater on the axis goes right.
So it's greater than on the right side, it's actually on the left side.
You only worry about greater or left or right if it's a perfect vertical line. If there is any slope to that line at all, any slope to it whatsoever, even if it's very, very, then greater would mean above and less would be below. You only think about it in terms of right and left if it's completely vertical. Alright, so undo.
You keep pushing the buttons.
I don't know what just happened.
I don't want to today.
Where did it go?
Press the back button up there.
Oh no, I think I like.
You like,
Dude!
delete your pages.
I don't like me being mocked over there.
You delete all your pages.
See, there it is, right there.
There we go.
Right there.
We're okay.
So,
Now,
is it different with left and right, like if it's a vertical line?
if it's completely vertical, greater is to the right, less is to the left. And it'll only bleed completely vertical if it's just an X. If there's a Y in it, then you don't have to worry about it. It'll just be above and below.
What about horizontal?
I'm glad you asked. I think that might come into play right here.
You gotta go up.
1, 2, 3, 4. Solid or dotted?
Solid.
I'm gonna
That's
take
like-
whatever. Just go with it.
And you said
Now, above or below?
drinks are
Wrong.
I'm sure.
Below.
Halo.
How do we
Yeah.
know? Why are you going over there?
I don't know, but I asked the question earlier.
Below is correct.
I'm just
Y is less, so it's below. Now, it would be all this, but I'm going to go ahead and cut to the chase and say, where will both shadings overlap?
right there.
Right.
On that one part.
Right there,
Yeah,
that's very
right there.
helpful. Right here.
No, one part.
So this part should be erased, and just this portion is the solution.
That part. We have to erase it?
Well, no, just make sure it's pretty obvious to me which section has both shadings. All right. I'm glad you think so. We're going to step it up a notch.
No.
In fact, I'll tell you what. Let's jump straight to the hardest problem. Yeah.
What if the line were over there? Like why is less than
There'd be no solution right now.
That's like bad makes it.
Say that again.
What if the line were y is less than
Then it would just be down here. Instead of positive 4, it would be negative 4, but it would just be down here. All right. Now, these systems of inequalities, they can be like 4 or 5 lines. You could graph like 4 or 5 things and come up with a little shaded portion. You're going to have one in your homework. There was no other examples for me to do that had 4, but there was one in your book where there was 3. So let's just do that one. You have to solve all of them for y that you can. This one you can't.
So do we have to shade each a different color?
I mean, no. If you're doing it in pencil, you might just do like one portion with like little right-handed dashes, then maybe left-handed dashes, and
So I
whatever.
didn't know if you wanted us to get like color pencil.
I mean, that'd be good if you had them, but you don't have to.
That's a lot of work.
Or you could just graph all 3 lines, just be like, okay, it's going here, 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 and just shade that one portion. Yeah,
That's probably what I'm doing.
all right, let's look at this one. First things first, you need to solve what you can for y.
Are we doing this alone?
We can.
No. I'd rather work it as a...
You
Can we
can.
solve for y first?
Yes, solve for y. Solve for LYO.
Camera.
You're solving for y.
Shut
Alright, so now that we solved them for y, let's graph them. All three of them. Let's cut me some axes up in here. Ooh, better yet, why don't you try to graph them and shade them accordingly? Alpha, okay, let's do it together then.
No.
Let's do it individually then.
Let me get my color.
Let me just pause there. Alright, first line. I will do in green. First one, y-intercept is -1. Slope is 1/2, up 1 over 2. Connect those dots with a solid line. Y-intercept of -1, slope of 1/2, up 1 over 2. Next one, which I will do in blue. I don't know what that is. Y-intercept of tree. Slope of -3/4. Down 3 over 4. I don't know what I'm doing. Graph those lines right
I
there.
don't either.
You can't see.
Is this a dotted line?
No. They've got equals. Now,
Which one is the X?
well, I tell you,
How do you know
if I said x is less than 1, here's x is 1, right?
What?
If I said x was less than 1, there's 1, right?
You
On
go
x.
straight up and down.
Yeah, so straight up and down. The only thing that makes this one hard is since it's at the origin, because x is 0, you kind of get confused on which axis it is. But remember, if it was x is 1, it'd be vertical, so x is 0 is going to be vertical.
It's gonna
You
be
can
up
say
and
the
down.
right.
Yes.
X is up and down.
Yes.
Have them all.
What?
Is dotted only when it has the no equal?
That's correct. So this is our x is 0 line. Now, we're just going to do all of our shading all at once. All of our shading all at once. Alright, we have to be greater than the green line, so above, less than the blue line,
Like,
so below, so above the green, below the blue.
like
So,
a 1-1. It's that little triangle.
how are we doing?
It's the
Above the
little
green,
triangle.
below the
It's over
blue,
there.
and to the right of the red.
It's the
No,
red,
it's
blue,
look,
green
It's in
triangle.
the triangle. Why are they to the left?
It's in.
Because x is greater.
Oh, oops, I thought it said less than that.
So it'll be this triangle right y'all.
Why would it be there?
Yellow.
Because that is the only portion that is above the green, below the blue, and to the right of the red.
Okay, my graphic. I thought it was the other triangle.
My paper is
Okay.
going to be destroyed in front of me.
Like
Why would it
saying.
be right there?
Because we have to appease all three parts of the equation. Less than, because it's less than the green line, which means, I'm sorry, greater than, my mistake. Greater than the green line, below the blue line, because y is less than, and because x is greater, to the right of the red line. Questions?
If the x is less than, would you just shade all the left side?
Yes, if x was less than, it would be that entire portion over there.
Yeah.
Yeah.
I don't, you can't see the line. Graph ain't big enough.
All right.
What happened to your pencil sharpener on the wall?
Yeah, I had someone disassemble it.
Do you have a pencil sharpener?
All right. The last thing you're going to be asked to do. The last thing you're going to be asked to do is look at a function, and you should be able to tell by the mutual shaded region what the entire systems of equations were. Now, here's the thing. When you have to come up with the system, they're going to be in slope-intercept form. Now let's just look at the first line. This one here. Where's the y-intercept of that line?
It's y-intercept 0.
0. What's the slope?
1 and 1.
Very good. So,
There's a goat vibe.
ladies, y-intercept of 0, slope of 1. Now, are we shaded above or below that line?
Below.
Below. Is it solid or whole?
Solid.
Solid. So it's going to have an equal sign. It's going to be less than. So y is less than or equal to. We said slope of 1, y-intercept of 0. So wouldn't that just be y is less than or equal to x Well, just x, right? Because 0, there's no point in adding that. First part, so good. Y is less than or equal to x plus 0. What about the second one? Is it going to be greater or less than?
Greater.
Is it going to be equal to or no?
No.
So y is greater than, what's the slope? 1. So y is greater than x. What's the y-intercept? Y is greater than x minus 3.
Yeah.
Very good.
How did you get minus 3?
Because that's where the y-intercept is.
That's
Now the one you have later, it might not be a perfect 1-1 slope, but there will be at least one point where you can be like, oh, that's up 2/3, 2/3, something like that. So, yeah, they might not be like perfect 1 slopes, but they will be eyeballable if you just look for another perfect point. Questions? Here you go.
what does BDN?
We've already talked about this.
Yeah, we already
Oh, but